Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Come feel the math love. We are doing rational functions and the end behaviors of those rational functions. Please notice these three f, g, and h are rational functions. It's a polynomial over a polynomial. And for rational functions, it's all about the ratio. The ratio. It's all about the ratio. The ratio. The ratio for rational functions. When the bottom gets big, the fraction gets small, approaching zero. Almost nothing at all. Do you see that the bottom degree is bigger than the top degree? The bottom is getting so significantly bigger than the top, right? When the bottom gets big. So if I plug in like a million, it's a million over a million squared. That bottom's getting really big. So the fraction gets small, approaching zero. Almost nothing at all. I hope that makes sense to you, that for a fraction, if the bottom's getting really big, the fraction's getting really small. Okay, so yes, this end behavior, it goes to zero. Okay, next, when the top gets big, the fraction gets large. Find the quotient. It's in charge. Find the quotient. Ooh, find the quotient. Ooh, okay. So we're going to find the quotient. If the top is getting bigger than the bottom, it's called the end behavior quotient. For right now, let's just know that it's going to positive and negative infinity. That's all we really need to know at the moment. But if you actually did the division and got a quotient, then you would go ahead and know that that was your end behavior. Okay, over here. Well, let me go back to this one for a second. We do know that when we do divide, we'll get a linear quotient. And so this is going to have what's called a slant asymptote because it'll have that linear end behavior. Okay, h of x. The quotient, you say, when degrees are the same, they're both squared. The quotient's the ratio. The quotient would just be the ratio of the leading coefficients. That's the end game. I do it like this because it's a horizontal asymptote. This going to zero is also a horizontal asymptote, like I said, because this one is 1 degree different. The top is 1 degree bigger than the bottom. It's going to be that slant asymptote when I find the quotient. The quotient here is going to be 6 divided by 3, so that's 2. So this one goes to 2. And it's going to be a horizontal asymptote. That's going to be that slant asymptote. That is all about the ratio, friends, and that's it. Sometimes we learn these as like a degree rule. So when the degree of the bottom is bigger than the degree of the top, when the bottom gets big, the fraction gets small, approaching zero. Almost nothing at all. And then we say, well, when the top degree is bigger than the bottom degree, then it goes to positive or negative infinity. The top gets big, the fraction gets large. Find the quotient. It's in charge. Find the quotient. Ooh, find the quotient. And if the degrees are the same, then it's the ratio of the leading coefficients. The quotient, you say? When degrees are the same, the quotient's the ratio. That's the end game. End game. Horizontal asymptote for that situation. Okay, friends. Listen to all about the ratio wherever you get your music. It's on Funky Functions. Oh my goodness, I can't speak right now. Subscribe, like, share, follow. Always remember that yes, indeed, you say math loves me and math loves you. Math loves you. Bye.